Good morning, students. Welcome back to the second session of chemistry. Today we are going to study chemical formula, balancing of chemical equation, relative atomic mass, relative molecular mass, calculation of relative molecular mass, and calculation of percentage composition. Now, in the previous lecture, we have learned about chemical formula. What is chemical formula? Element or compound is represented by symbols. Representation is known as chemical formula. Now there are certain steps while writing the chemical formula. Now let us consider the example of sodium oxide. So first you need to write the symbol of the elements. Now always remember that metal is written on left hand side and non-metal is written on right hand side. Now what is the symbol of sodium? Sodium Na and oxide, that means oxygen, you have to write O. Now the valency number of the symbol you have to write. Sodium is having 1 and that of oxygen is 2. So after interchanging the valency number, the formula becomes Na2O. So the formula of sodium oxide is Na2O. Take second example, potassium chloride. Symbol of potassium K, that of chloride is Cl. So potassium is having +1 and chloride -1. After interchanging, the formula becomes KCl. And always remember that whenever non-metal is there, it has got the suffix IDE. It is written with the suffix IDE, like oxygen will be written as oxide, chlorine will be written as chloride. Next is potassium dichromate. Now formula of potassium is K and that of dichromate is Cr2O7 -2. So potassium is having valency 1 and that of chromate is 2. So after interchanging, it becomes K2Cr2O7. Ammonium sulfate. The formula of ammonium is NH4 and that of sulfate is SO4 -2. Valency of ammonium is 1 and sulfate is 2. So after interchanging the valency number, it becomes NH4 twice SO4. Same example you can write for sodium chloride. If formula of sodium chloride is asked, sodium formula is Na, chloride is Cl. Sodium is having valency +1, that of chloride is -1. So after interchanging, it becomes NaCl. If you are asked to write the formula of calcium sulfite, so Ca and here radical SO3, that is sulfite. Calcium is having valency 2 and that of sulfite is also 2. So, but calcium +2 and sulfite -2. So, it gets cancelled. So, the formula of calcium sulfite will be CaSO3. So, in this way, in the exam, they may ask you to write the chemical formula of certain compounds. Now, always there are exceptions everywhere. So, in chemistry also, there are few exceptions. Now, let us see the example of few exceptions. Now, let us consider the example of first compound. You can see Cu in bracket NH3,4SO4. Now, all of you know we have learned about the types of valency mono, di, tri and tetra. So as here 4 is there, it will be tetra. So name of the compound will be tetraamine copper sulfate. Second example, ZnNH3,4SO4 minus. Now here also it will be tetraamine zinc sulfate. Always remember when SO4 is there, we use suffix ATE, and if it is 3, we use the suffix ITE. Next, AgNH3 twice Cl. Now, if it is 2, it is di. So, diamine silver chloride, KClO. Now here, depending on the number of oxygen atom, the suffix is changed. So if it is KClO, we write potassium hypochlorite. If it is KClO twice, it becomes potassium hypochlorite. KClO3, it becomes potassium hypochlorate. And KClO4, potassium perchlorate. So you can see when it was a single oxygen, it is chloride, O2, potassium chloride. Then KClO3, it is potassium chlorate, and KClO4, potassium perchlorate. So these are the few exceptions which are given in your book. So you need to learn the formula as well as the name of this. Now let us study about the chemical equation. A chemical equation is a shorthand form for a chemical change. A chemical equation shows the result of chemical change in which the reactants and the products are represented by symbols and formulae. Now let us first understand what are reactants and products. Now the substances which take part in chemical reaction are called reactants, and reactants are always written on left hand side. This you must have learnt in grade 8. Then products. The substances formed as a result of chemical change are called as products. Products are always written on right hand side. So here there are two important concepts. One is product and one is reactant. So what are reactants? Substances which take part in chemical reaction are reactant, and substances which are formed as a result of chemical change are called as products. Reactants are always written on left hand side and products are always written on right hand side. Now, what information is provided by this chemical equation? Chemical equation tells us about the chemical nature of reactant and product. Then it tells us about the nature of the elements and radicals which are involved in the chemical equation. Then it tells us about the direction of the reaction. Now there are two type of reaction. One is reversible and one is irreversible. So if it is a straight line with an arrow, it is irreversible, and if the arrow is it is two-headed, it is reversible. Then it tells us about the state of matter in which the substance is present. If it is solid, it is written as S. If it is liquid, it is written as L, and if it is gas, it is written as G. Now, let us see the example of chemical equation. Now, there are different type of chemical equation. First, one reactant and two products. Now, here in the first example, you can see that calcium carbonate when heated gives calcium oxide and oxygen. Now, calcium carbonate is a reactant and it gives calcium oxide and oxygen. So, reactant reacts to one reactant react to give two products. Here calcium carbonate is a reactant which react to give two products, calcium oxide and oxygen. Now calcium carbonate is a reactant, so it is written on left hand side, while calcium oxide and oxygen are products. Both of them are written on right hand side. So this is example where one reactant reacts to give two products. Now second example where two reactants react to give a single product or one product. Now hydrogen reacts with chlorine to form hydrochloric or hydrogen chloride. So here hydrogen and chlorine, both the reactant react to give single product, that is hydrogen chloride. The next example, two reactants react to give two products. Now here sodium hydroxide react with HCl to give NaCl and water. So this is an example of neutralization reaction which we will study further, where NaOH is a base, HCl is an acid. So acid and base react to form salt and water, that is NaCl and H2O. So here two reactants, they react to give two products. Now next, two reactants and three products. Now NaHCO3, that is sodium bicarbonate, react with HCl to form salt, water and carbon dioxide. So always remember, whenever carbonate is there in the reactant, carbon dioxide is formed as the product. So sodium bicarbonate and HCl react to form salt, water and carbon dioxide. So this is example of chemical equation where two reactants react to give three products, that is salt, water and carbon dioxide. Now next, two reactants react to give four products. Now potassium permanganate, when treated with acid, that is HCl, it forms potassium chloride, manganese chloride, water and chlorine. So here two reactants react to give four products. And always remember that chlorine is greenish yellow color gas. So this is all about example of chemical equation. There are total 5 types we have seen, where one reactant react to give two products, two reactant reacts to give one product, two reactants react to give two products, two reactants react to give three products, and two reactants react to give four products. Now let us study about balanced chemical equation. What is balanced chemical equation? You must have learned this in grade 8. Now there is always a question asked in the exam, that balanced equations. Balanced chemical equation is one in which the number of atoms of each element is same on the side of reactant and on the side of product. So the number of atoms of each element must be same on reactant as well as that of product side. Now why equation should be balanced? Equation should be balanced in order to follow the law of conservation of matter. We state that matter is neither created nor destroyed in course of chemical reaction. It just changes from one form to another form. Now let us see the upcoming video to understand the concept of balanced chemical equation more in detail.
Example. Just imagine we carry out an experiment in which element A and element B react together to give us a compound C. If we keenly observe, we find that atoms of elements A and B do not exist individually in the reaction mixture. They come together to give us the new compound C. Although it seems that atoms of elements A and B are degenerating, it's not the case. In reality, they are combining to give us the compound C. Antoine Lavoisier put forth the law of conservation of mass, and do you know what it tells us? It states that mass can neither be created nor destroyed in a chemical reaction. He explained this law by saying that matter is formed from the pre-existing matter, and the mass of the newly formed matter will be the same as that of the pre-existing matter. We can neither create new matter nor destroy the existing.
Now for balancing equation, there are different methods used. Now we are going to see the hit and trial method. Now let us consider the example where nitrogen reacts with oxygen to give nitric oxide. Now N2 plus O2 gives NO. Now if you see the reactant on the right hand side, nitrogen is having two atoms, oxygen 2. On the left hand side, N1 and oxygen also 1. So to balance the atom on both the side, that is reactant and product, we need to multiply the product side with 2. So it becomes N2 plus O2 gives twice NO. Second example, where magnesium reacts with nitrogen to form magnesium nitride. Now in the first case, magnesium on the reactant side is 1 and that of nitrogen is 2. While on the product side, Mg is 3 and nitrogen 2. So To balance the equation, the number of atoms on magnesium is not equal. On the product side it is 3, while that on the reactant side it is 1. So we need to multiply the reactant side with 3, while nitrogen is same on both the side. So thrice Mg plus N2 gives Mg3N2. That is, magnesium reacts with nitrogen to give magnesium nitride. Now next example, where iron reacts with water to form iron oxide and hydrogen. Fe plus H2O gives Fe3O4 plus H2. So Fe on the reactant side is 1, hydrogen is given 2, oxygen is 1. So Fe on the product side is 3. So we need to multiply reactant with 3. Hydrogen is on the product side is 2, while that of the on the to make it same on the reactant side we need to multiply both of them with 4, and oxygen is 4. So on the reactant side we need to multiply it with 4. So it becomes 3Fe plus 4H2O gives Fe3O4 plus 4H2. So iron reacts with water to form iron oxide and hydrogen. So number of atoms on both the sides are same. Now next, sulfur reacts with nitric acid. You have seen in the list of the compound where we have studied the name of the acid. So sulfur reacts with nitric acid to form sulfur dioxide, nitrogen dioxide and water. Here sulfur is 1 on reactant side, on product also 1, hydrogen 1 on reactant side, hydrogen 4 on product side, nitrogen 1 on both the side, oxygen is 3 on the reactant, while oxygen is 7 on the product side. So total we need 6 hydrogen. So sulfur plus 6 HNO3, that means sulfur reacts with nitric acid to give sulfuric acid, nitrogen dioxide and water. So S plus 6 HNO3 will give you H2SO4 plus 6 NO2 plus 2 H2O. So just check the number of atoms on oxygen, hydrogen and nitrogen. So the number of atoms on reactant as well as the product side is same. Now when ammonia, all of you know NH3, it reacts with oxygen or it undergo oxidation to form nitrogen and water. Here on the reactant side nitrogen is 1, while that of product it is 2. Hydrogen is 3 on reactant, while product side it is 2. Oxygen 2 on reactant side, while on product side it is 1. So to balance it, the equation becomes 4NH3 plus 3O2 gives 2N2 plus thrice H2O. So the number of atoms on the reactant as well as the product side is same and it is balanced. So in this way, the balancing of equation is done. Okay. Now sometimes the equation is written in word form, which we called it as a word equation. So in the exam, they may ask you word equation also. So they will not provide you with the symbols and the formula which is given for balancing of equation. So you need to know the formula also of the compounds. For example, lead dioxide gives lead monoxide and oxygen. Dioxide means it is having 2 oxygen. So the equation goes PbO2 when heated gives lead monoxide means PbO plus oxygen, that is O2. So we need to balance the equation on the reactant as well as the product side. It will be 2PbO2 gives 2PbO plus O2. So lead dioxide when heated gives lead monoxide and oxygen. Now nitrogen dioxide when treated with water and oxygen gives nitric acid. So what is the formula of nitric acid? HNO3, which is used in the laboratory. Now here nitrogen dioxide means first we'll write NO2 plus water H2O plus oxygen O2 gives HNO3. So on the reactant side, the equation will be balanced like 4NO2 plus twice H2O plus O2 gives 4HNO3. So the equation is balanced on both the side, that is reactant as well as the product side. You have to check the number of hydrogen atom, the number of oxygen and nitrogen also. So this is all about balancing of equation and word equation. Now let us see the upcoming video to understand the concept of balancing equation more in detail.
Oxygen, and water. And we saw the reason why this chemical equation is unbalanced. The number of oxygen atoms on the left is not equal to the number of oxygen atoms on the right. The important question is, can we balance this equation? The answer is yes. Let's go step by step and see how we can balance it. As the first step, it's always a good idea to draw boxes around each element or compound, like this. Why did we draw these boxes? It's because nothing inside the boxes can be changed or altered when we are balancing the equation. You'll understand better soon. Next, we form a table like we've already drawn here. This row in the table tells us that the number of atoms of oxygen on the reactant side is not equal to that on the product side. It's 2 on the left and 1 on the right. So let's try balancing the oxygen atoms first. As there's 1 oxygen atom on the right and 2 on the left, we multiply H2O with 2. What we have here is a partially balanced equation. The number of oxygen atoms on the right is 2 and that on the left is also 2. Also remember that you cannot alter the formulae of compounds or elements involved in the reaction, which means that to balance the oxygen atoms, we cannot change H2O and write it as H2O2. This would be incorrect. Let's go back to the partially balanced equation. The number of oxygen atoms on each side is balanced now. But what about hydrogen? When we multiplied this compound with 2, what happened? The number of oxygen atoms were equal on each side, but what about hydrogen atoms? The number of hydrogen atoms on the right became 4. And what's the number of hydrogen atoms on the left? It's 2. So how do you think we can balance the hydrogen atoms now? We can multiply the hydrogen on the left-hand side with 2 to get this. Is the equation balanced now? Absolutely. We can form the table and verify it. This is what you'll get. So we simply multiply the appropriate elements or compounds as necessary to balance each and every element. When all elements are balanced, we say that the chemical equation is balanced. Easy, wasn't it? Why don't you try balancing this chemical equation? You'll see the solution in the next part of the lesson. What's the first step we can do? We draw boxes around each element or compound. The purpose of these boxes is to make sure that you don't change anything inside the boxes. Whatever you want to multiply, you do it to the entire box and not just one particular element. Next, we populate this table. In the first column, we write down the different elements involved in the reaction. And then in these two columns, we write the number of atoms each element has on each side of the equation. Why don't you try filling up this table? Which are the elements or atoms present in the equation? Iron, hydrogen, and oxygen. That's right. If you've not tried it yet, try filling up these two cells for each element. This is how the table would look. You see that iron and oxygen are not balanced in this equation. So the important question is, which atom should we start balancing first? Should it be iron or should it be oxygen? That's where the third step comes in. Look for the atom which is maximum in number on any side. If we look at this table, the maximum number is 4 and it's on the right. Oxygen in this compound has 4 atoms. So our first aim will be to balance the oxygen atoms. On the right, it's 4 and on the left, it's 1. So to balance the number of oxygen atoms, we multiply this compound with 4. So the number of oxygen atoms on each side is 4 now. This is a partly balanced chemical equation. But the iron and hydrogen atoms are not balanced now. When we multiplied this compound with 4, the number of hydrogen atoms on the left became 8 and that on the right is still 2. As the number of hydrogen atoms is 8, let's proceed with balancing the hydrogen atoms next. As it's 8 on the left and 2 on the right, we multiply the hydrogen on the right with 4. Is the equation balanced now? The number of oxygen atoms on each side is 4 and the number of hydrogen atoms on each side is 8. And what about iron atoms? It's 1 on the left and 3 on the right. So the equation is just partly balanced. So to equalize the Fe atoms, we multiply Fe on the left with 3. Is the equation balanced now? Yes, it is.
Now student, let us understand about relative atomic mass. Now atoms, as you all know, they are extremely small and very light, hence they cannot be weighed directly. So indirect methods have been utilized to determine the absolute mass of atom. Now here, while comparing the mass of the atom, carbon-12 isotope is taken into consideration. So isotope means they have same number of proton but different number of neutron. And carbon is considered as a standard for comparison of mass of other atoms or molecules. Now here we are going to study relative atomic mass. Means it is a number of times one atom of an element is heavier than 1/12 of the mass of carbon. As I have already told you that carbon is taken as a standard. So relative atomic mass is nothing but atomic weight. It is also called as RAM, that is relative atomic mass. It tells us about about the number of times of an atom of an element is heavier than 1/12 of the mass of carbon. It is expressed in gram atomic mass or gram atom of an element. Now relative molecular mass. It is also called as RMM. It gives us the information. It tells us about the molecular weight. Now let us first understand what is the difference between atom and molecule. In RAM, that is relative atomic mass, it tells us about the atom, and in relative molecular mass it tells us about the molecule. Now what is the difference between atom and molecule? Atom is the smallest particle of an element, while atoms, they combine together to form molecule. So relative molecular mass of a compound is number of times molecule of a substance is heavier than 1/12 of the mass of atom of carbon. So relative molecular mass is written as mass of one molecule of substance upon 1/12 of the mass of one atom of carbon. And gram molecular mass is expressed in gram molecular mass or gram molecule of that element. In the upcoming video, let us understand the concept of relative atomic mass and relative molecular mass more in detail. This will help you to solve the numericals.
Relative atomic mass, relative molecular mass, and relative formula mass. An atom is too small and tiny to be weighed by any instruments. A more practical way to determine the mass of an atom is by comparing its mass with the mass of a standard atom. In modern scale, carbon-12 is used as a standard atom. Relative atomic mass of an element is the number of times the mass of an atom is greater than 1/12 of the mass of a carbon-12. The relative mass of a carbon-12 atom is 12. For example, if a magnesium atom is 24 times greater than 1/12 of the carbon-12 atom, thus, the relative atomic mass of magnesium will be 24. Just a quick note, the relative atomic mass has no units. Relative molecular mass can also be determined through comparison with the carbon-12 atom. Relative molecular mass of a substance is the number of times the molecule is greater than 1/12 of the mass of a carbon-12. For example, if a carbon dioxide molecule is 44 times greater than 1/12 of the carbon-12 atom, thus, the relative molecular mass of carbon dioxide will be 44. The relative molecular mass for a molecule can be calculated using molecular formula of the substance and the relative atomic mass of each element in the molecule. In the case of carbon dioxide, the relative molecular mass can be calculated by adding up all the masses of relative atomic mass in carbon dioxide molecule. Thus, the relative molecular mass of carbon dioxide is 44. For ionic compounds, the term relative formula mass is used to replace the term relative molecular mass. Relative formula mass of an ionic compound is the number of times the ionic compound is greater than 1/12 of the mass of a carbon-12. The method used to determine relative formula mass is similar to the method used to determine the relative molecular mass of substance, that is, sum up all the masses of relative atomic mass in the ionic compound. For example, relative formula mass of magnesium oxide is 40. Relative formula mass of aluminum chloride is 133.5.
Now let us study about the calculation of relative molecular mass, or say molecular weight. Now let us consider it is calculated by adding atomic weight. First thing, let us consider the example of nitrogen dioxide. Now before solving this example, children, let me tell you one thing, that atomic weight of the element will be provided to you in the exam also. Now molecular weight of nitrogen dioxide. First of all, nitrogen dioxide, you should know the formula. Nitrogen oxide formula is NO2. Now what is the atomic weight of nitrogen given? It is 14, and that of oxygen is 16. So now we have to calculate the molecular weight of nitrogen dioxide. For that, we have to write the formula atomic weight of nitrogen plus 2 into atomic weight of oxygen. Why 2 into atomic weight of oxygen? Because oxygen is taken twice over here, that is O2. So it will be weight of nitrogen is 14 plus 2 into, what is the atomic weight of oxygen given? It is 16. So 14 plus 16 twos are 32. So it becomes 46. So molecular weight of nitrogen dioxide is 46. Now next example, relative molecular mass of calcium sulfate. Now calcium sulfate, the formula of calcium is Ca and that of sulfate is SO4. So it becomes CaSO4. Atomic weight of calcium is Ca is 40 and atomic weight of oxygen is 16, and while that of sulfur is 32. So here we'll put the values, calcium 40, sulfur is 32 plus 4 into 16 because O4 is given. So it is 40 plus 32 plus 14 6 are 64. So total addition is 136. Molecular weight of calcium sulfate is 136. So in this way, you have to calculate the molecular weight of the compounds. In the exam, they may ask you for 1 or 2 marks. Now student, let us understand about the percentage composition. Let us take example of different marks which you score in different subjects. While taking out the percentage, you add them and then take out your percentage, right? In the same way, the percentage composition of element is also taken. To find out the percentage of element, you have to divide it in this way. that mass of element in the compound divided by its molecular weight or molecular mass of compound into 100. So percentage composition of element is mass of element in the compound divided by molecular weight of compound into 100. Now let us consider the example of carbon dioxide. Now formula of carbon dioxide is CO2. Atomic weight of carbon is 12 and that of oxygen is 16. So molecular weight is 12 plus 32, that it becomes 44. Now 44 gram of carbon dioxide contains 12 gram of carbon, right? Atomic weight of carbon is 12. So for 100 gram of carbon dioxide contains 12 divided by 44, that is molecular weight of carbon dioxide. 12 is the atomic weight of carbon into 100. So the percentage of carbon is 27.27. Now of oxygen. Now what is the weight of oxygen? Atomic weight is 16. It is O2, so it becomes 16 2s are 32. So 44 gram of carbon dioxide contains 32 gram of oxygen. So 100 gram of carbon dioxide contains 32 divided by 44 into 100. So it is 72.73. If we add the percentage of carbon and oxygen, it becomes 100. Okay. So in this way, you have to calculate the percentage composition of the given compound. In the exam, they may ask you to find out the percentage composition of compound. It's very important. So you need to remember the formula. Once more, I'm again revising it, that the percentage composition of element is mass of element in the compound divided by molecular weight of that compound into 100. So please solve the numericals which are given in your textbook on page number 12 and 13 of your textbook for practice.